Hi, we are discussing the second part of plus 1 chemistry, some basic concepts of chemistry. So we have starting with Dalton's atomic theory. These are the postulates of Dalton's atomic theory, and matter is made up of small indivisible particles called atoms. Atoms of same element are identical in mass and other properties. Atoms of different elements are different in mass and other properties. Atoms can neither be created nor be destroyed. Since atoms are indivisible, they combine in small whole numbers to form compounds, atoms called molecules. So these are the postulates of Dalton's atomic theory. He first postulated about atoms. Atoms are indivisible and atoms combine to form molecules. Atoms of same element are identical and different elements are different in their properties, and atoms can neither be created nor be destroyed. Next is atoms and molecules. Atom is the smallest possible unit of matter that exhibit all the properties of matter that may or may not have independent existence. A molecule is the smallest unit of matter which exhibits all the properties of that kind of matter and is capable of independent existence. So that are atoms and molecules. We know that hydrogen is an atom, oxygen is an atom, and water. Molecule, example for molecule is water. So water is a molecule, and molecule have all the properties of that substance. Since water is a compound, water molecule have all the properties of that water compound, or atom do not have all the properties of water, and we know that water is consists of hydrogen and oxygen. Hydrogen is a gas which will burn, oxygen is a gas which will help to burn, but water, which formed by the combination of these two atoms, is the compound which will destroy the fire. Okay, so a compound which, or a molecule, is that have all the properties of that compound, and atoms do not have all the properties of that compound. So there are types of molecules. Molecule containing only one type of atom is called a homonuclear molecule. Examples are hydrogen, oxygen, nitrogen, ozone, etc., which are formed by same types of atoms. And molecules containing different types of atoms are called heterogeneous molecules. Carbon dioxide, water, glucose, ammonia, etc. are examples of heteronuclear molecules which have different types of atoms in their molecules. And types of molecules based on number of atoms. They are monoatomic molecules which contain only one atom. Metals, noble gases like helium, neon, argon, etc. are examples of monoatomic molecules. These are molecules actually, but they have only one atom in their molecule. And diatomic molecules which have two atoms. Hydrogen, oxygen, nitrogen, halogens are examples of diatomic molecules. Polyatomic molecules which contain more than two atoms in their molecule. Ozone is an example. Ozone molecule is formed by combination of 3 oxygen atoms. Phosphorus formed by 4 phosphorus atoms. Sulfur is a molecule formed by 8 sulfur atoms, etc. These are types of molecules. And what is atomic mass? It is mass of an atom, right? Atomic mass of an element is defined as number which expresses how many times the mass of one atom of element is greater than 1/12th mass of carbon-12 atom. Actually, atomic masses were expressed in terms of carbon-12. So, we can say that atomic mass is mass of atom, or we can compare it with the mass of carbon-12 atom, and we can say that atomic mass is, or it expresses how many times mass of one atom of element is greater than 1/12th mass of carbon-12 atom, and carbon-12 atom have a mass of 12. 1/12th of that means it is 1. So if hydrogen, and we know that hydrogen have an atomic mass of 1, so it is 1 times greater than, or it is same to the mass of one atom of element greater than 1/12th mass of carbon-12 atom. So nitrogen have an atomic mass of 14. So we can say that nitrogen have atomic mass which is 14 times greater than mass of 1/12th mass of carbon-12 atom. Okay. So atomic mass is mass of one atom of element divided by 1/12 into mass of one carbon-12 atom. atomic mass unit. One atomic mass unit is defined as mass exactly equal to 1/12th mass of one carbon atom, and atomic mass unit is also known as unified mass. Okay. One atomic mass unit is 1.66 into 10 raised to minus 24 kilogram. So, mass of an atom of hydrogen is 1.67 into 10 raised to minus 24 kilogram. Mass of hydrogen atom in terms of atomic mass unit is 1.6736 into 10 raised to minus 24 divided by 1.66056 into 10 raised to minus 24 gram. So we can convert this atomic mass unit into kilogram and gram, and we know that these are almost same units, but atomic mass is expressed in terms of atomic mass unit generally. Okay, and 1.67 into 10 raised to minus 24 grams is mass of one atom of hydrogen. Okay, it is gram, it's not kilogram, it is gram. We can convert this from this to kilogram also. And next is molecular mass. What is molecular mass? It is the mass of molecule. It is the sum of atomic masses of elements present in a molecule, and we can obtain it by multiplying atomic mass of each element by number of its atoms and adding them together. So we can calculate the molecular mass of carbon dioxide by combining atomic mass of carbon is 12, atomic mass of oxygen is 16, so it is two oxygens there. So the total atomic mass is 32 plus 12, that is 44. So like this we can calculate the molecular mass of every molecule. Next is gram atomic mass or gram atom. Atomic mass expressed in grams is called gram atomic mass or simply gram atom. Generally we express atomic mass in atomic mass unit or unified mass, and we can express it in gram also. So we can say it is gram atomic mass or simply gram atom. Number of gram atoms is equal to mass in grams divided by gram atomic mass. Next is gram molecular mass. Molecular mass expressed in grams is called gram molecular mass or simply gram mole. Next is formula mass. Formula mass of a molecule is sum of atomic weights of the atoms in the empirical formula of compound or formula of the compound. For example, in case of sodium chloride, its formula mass or its formula is sodium chloride. Since it is expressed as a crystal, so we express it, or we say it is the formula of sodium chloride is NaCl, and we can find the formula mass by adding its atomic masses together like in the formula. So since sodium chloride's formula is NaCl, we can say that sodium have atomic mass of 23, chlorine have its 35.5. Since these are all 1, so we can add this and find the formula mass of compound. Next is mole concept. It's very important concept. Mole is the unit used for counting very large number of particles like atoms, molecules or ions. And we can say that the number of something, amount of substance is expressed in moles. Okay. And mole is the unit used for counting very large number of particles like atoms, molecules or ions. And 1 mole is equal to 6.023 into 10 raised to 23. So this much of particles is there in 1 mole of any substance. We can say that 1 mole of hydrogen contains 6.023 into 10 raised to 23 particles. So it is very huge quantity. So we define this as 1 mole. And mole is represented by the symbol MOL. Next is molar volume. Volume occupied by 1 mole of a gas is called molar volume or gram molar volume. 1 mole of all gases occupies 22.4 liter at STP. That is, if we consider carbon dioxide molecule, then what is its number of particles? It will be 6.023 into 10 raised to 23. And what will be its volume? It is 22.4 liter every time. Okay, so when we take 1 mole of any substance, it will have 6.023 into 10 raised to 23 particles and 22.4 liter as volume. This is the mole concept simply. So 1 mole of any substance contains 22.4 liter at STP. So 1 mole of hydrogen contains a volume of 22.4 liter. 1 volume of oxygen contains 22.4 liter at STP. 1 mole of water contains 22.4 liter at STP, and we can say that all gases contains 22.4 liter at STP when it is 1 mole, and 1 mole is equal to 6.023 into 10 raised to 23 particles. And we can say that mass of 1 mole of any substance is equal to its molar mass. So 1 mole of carbon dioxide means it have how many grams? It is 44 grams of carbon dioxide, and it will be 6.023 into 10 raised to 23 particles, and it's equal to 22.4 liter. So that's about molar volume. Next is percentage composition. Mass percentage of an element can be found by this equation. Mass of that element in the compound divided by molar mass of the compound into 100. So how can we find molar mass of any hydrogen? If we have to find mass percentage of hydrogen, then we have to find molar mass of water. It is 8 grams, since hydrogen have a atomic mass of 2 and oxygen have it is 16, and 18 is molar mass of water. So mass percentage of hydrogen will be 2 into 1, that is 2 divided by 18 into 100, and mass percentage of oxygen will be mass of that element in compound, that is 16 divided by 18 into 100. So using this we can find the mass percentage of any element. So next is empirical formula. Empirical formula is the simplest whole number ratio of various atoms present in a compound. For example, empirical formula of benzene is CH. We know that the molecular formula of benzene is C6H6, and since both have 6 in them, we can divide this with 6, and we can say that the empirical formula of benzene is CH. Or we can say that in case of C6H12O6 glucose, then we can say that this is the molecular formula or actual formula, and what will be the empirical formula? We can divide all with the 6 so that we get CH2O. That is the empirical formula, or this is the simplest whole number ratio of atoms present in a compound. Next is molecular formula. What is molecular formula? It gives exact number of different types of atoms present in a molecule of a compound. For example, molecular formula of benzene is C6H6, and it is the actual formula. So relation between empirical formula and molecular formula. Molecular formula is equal to N into empirical formula, where N is molecular mass divided by empirical formula mass. For example, we can find the empirical formula of, or we can find the N of benzene, C6H6. So molecular formula is equal to N into empirical formula, and we know that the empirical formula of benzene is CH. And how we can find the molecular formula of this benzene? We can multiply empirical formula into N. And how we can find N? Molecular mass divided by empirical formula mass. Molecular mass is, so here we have C6H6 as molecular formula. So molecular mass is 12 into 6 plus 6 into 1. 12 into 6 is 72. 72 plus 6 is 78. So molecular mass is 78 divided by empirical formula mass is 12 plus 1, it is 30. So 78 divided by 13 is 6. So we get N as 6, and we can find molecular formula by multiplying 6 into empirical formula. Okay. So we will get C6H6 as molecular formula. Next is stoichiometry. Stoichiometry is from two Greek words. Stoichon mean element and metron mean measure. So stoichiometry deals with calculation of masses of reactants and products involved in a chemical reaction. Example is methane plus 2 oxygen gives carbon dioxide plus water. Here 1 mole of methane reacts with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Actually we can find the number of moles by finding the left number in the formula. So here CH4 left there is only 1, or here there is no number is denoting, so we take it as 1. So 1 mole of methane react with the 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Or we can say that 1 mole contains, always 1 mole contains molecular mass of that compound. So 1 mole of methane means molecular mass of methane, that is 12 plus 4, 16. 16 gram of methane reacts with 2 moles of oxygen. 1 mole of oxygen contains 32 grams. So 2 moles contains 64 grams of oxygen to give 1 mole of carbon dioxide, that is 44 gram, and 2 moles of water. 1 mole of water have 18 grams. So 2 moles of water have 36 grams. So we can write this, or we can write it in terms of volume, that is 1 mole of methane, that is 22.4 liter of methane with 2 moles of oxygen, or 2 into 22.4, that is 44.8 moles of oxygen combined to form 1 mole of carbon dioxide, that is 22.4 liter in volume, plus 2 moles of water, that is 44.8 liter in volume. So we can say like this, and we can say it in terms of number of particles also, that is 6.022 into 10 raised to 23 particles of methane, and 2 into 6.022 into 10 raised to 23 particles of oxygen combined to form 6.022 into 10 raised to 23 particles of carbon dioxide, and 2 into 6.022 into 10 raised to 23 particles of water. So this is exactly the mole concept. If you get this, then you can solve all the questions related to mole concept. So 1 mole of every substance contains 6.022 into 10 raised to 23 particles, and it have a mass of equal to molar mass, and it equal to a volume 22.4 liter. So next is reactions in solutions. First is mass percentage. Mass percentage of a component in a given solution is mass of the compound per 100 gram of solution. That is, mass percent is equal to mass of solute by mass of solution into 100. Next is mole fraction. Ratio of number of moles of one component to the total number of moles of the solution. So number of moles of component divided by total number of moles of all the components. If a solution have substance A and substance B, then mole fraction of A will be number of moles of A divided by number of moles of A plus number of moles of B, and correspondingly number of moles of mole fraction of B will be equal to number of moles of B divided by number of moles of A plus number of moles of B. And in case of a solution which have two components, then mole fraction, sum of mole fractions will be equal to 1, and if it have a 10 components in a solution, then mole fraction, sum of mole fractions of this 10 components will be equal to 1. So next is molarity, and it is number of moles of solute in 1 liter of solution, or we can find molarity as number of moles of the solute divided by volume of solution in liter. It is denoted by capital M. Then what will be molality? Molality is number of moles of solute divided by mass of solvent in kilogram. And next is normality, and it is defined as number of gram equivalents of the solute dissolved in 1 liter of solution. Number of gram equivalents of solute by volume of solution in liter. Next is limiting reagent. The reagent which is completely consumed in a chemical reaction is called limiting reactant or limiting reagent. For example, in this reaction, 2SO2 plus O2 gives 2SO3. 2 moles of SO2 reacts completely with 1 mole of oxygen to form 2 moles of SO3. So if we take 10 moles of each of SO2 and O2, what will happen? Does the 10 moles of SO2 and 10 moles of O2 react completely? We have to find it from the given data. So 2 moles of SO2 is reacting with 1 mole of oxygen. So 2 moles of SO2 needs 1 mole of oxygen. So 10 moles of SO2 needs how many moles of oxygen? It needs only half of this, that is 5 moles of oxygen is needed. Okay, so we have 10 moles of SO2 and 10 moles of oxygen, but only 5 moles of oxygen is needed. So if we have to react 10 moles of O2, then we must have a 10 into 2, that is 20 moles of SO2, but we have only 10 moles of each SO2 and O2. So here we can say that SO2 is the limiting reagent. Okay. So here SO2 is limiting reagent and 5 moles of O2 remains unreacted. This is the example of limiting reagent. Or we can say that if we have 1 cup of water and 1 cup of milk. Okay, this is milk. 1 cup of water and 1 cup of milk to get 2 cup of tea. Okay, we have to prepare 2 cup of tea, so that we must have 1 cup of water and 1 cup of milk. And if we have 3 cup of water and 2 cup of milk, then what will we do? We can take 2 cup of water and 2 cup of milk and prepare 4 cup of tea. Okay, and 1 cup of water is unreacted because we do not have enough milk. So from this we can say that milk is the limiting reagent, or we need a 3 cup of milk for preparing 6 cup of tea, but we don't have enough milk, so we can say that milk is the limiting reagent. Like this, in a reaction we can find the amount of limiting reagent from the equation itself and from the given data.